To start this section 6.3, let's try to do this. Suppose we try to find f inverse for this function right here. F of x is, let's make it an exponential function, say 5 to the x. So we know what to do here. What we'll start with is to replace f of x with y, just for convenience. We get 5 to the x. And now what we do is that we interchange x and y, and that gives us x equals 5 to the y, and then we solve for y. But do you remember we did something like this in the last section, and we got to this point right here, x equals something to the y? Well, we have no algebraic way of solving for y right now. Right? This equation is not this. It's not x equals 5y, which case I could just divide by 5, but that's not what we have. We have 5 raised to the y, and we have not solved any equations where the variable is in the exponent. So we have no algebraic way of doing this right now. So what we're going to do is we're going to make a definition. We're just going to say what y is, right? X equals 5 to the y. What is y? We're going to say what it is in a definition. So we're going to write a definition, so we'll make it general. So what I'm going to do is I'm going to let b be some number, right? B be a constant greater than 0, not equal to 1. And I'm going to write this. If you have something like this, x equals b to the y. Now down here, in our problem over here, our b, our base, was 5. All right, but I'm just writing in general. It could be any base as long as it's positive, not equal to 1. So if you have this, that is going to be equivalent to this. Here's what y is. Here it comes. Y is equal to, and I'm going to write this, log, kind of a subscript for a b, of x. Let's read through this. So if you have x equals b to the y, here's what y is. We say y is the logarithm base b of x. And when I write this, I'll do it a little bit bigger here. Kind of looks like this. All right, when I write it, it's kind of like this, right? Those are on the same line, and the b is a little bit lower. The b is down here kind of as a subscript. So just what is this y? We're saying y is a logarithm. So what is a logarithm? Well, look back up here. What is y? Y is an exponent. So a logarithm is just an exponent. So there's really nothing all that mysterious about them. When you say logarithm, just think exponent. Let's try a few examples. How about the first one here? I'm going to write a truth statement. 2 to the third is equal to 8. Now that's an exponential form. I'm going to convert this to logarithmic form. And when I look at this, I'm going to kind of write what I say here. What do I know? The exponent here is 3. So 3 is the exponent. But what I'm going to write is 3 is the exponent. But I'm spelling exponent by log, so I'm going to write it like this. 3 is the exponent, log. And what's the base? Right, the base here is 2. And if you follow it up here, that's the b, right? That's our base. That goes on as a subscript down here of 8. So I've converted the exponential form to the logarithmic form. So 3 is the exponent. 3 is the exponent. Exponent is just logarithm. Logarithms, exponent, same thing. And what's the base? 2 of 8. Let's try another one here. How about this? If we say that 4 squared is 16, that's the exponential form, what's it look like in logarithmic form? Well, 2 is the exponent, but exponents are logarithms. So what I'm going to write here is 2 is the exponent, but exponents logarithms. The base here is 4, so I drop that down of 16. And then this number 3, look at this expression here. This is kind of new to us. We're not used to reading things like that. But here's all I have to keep in mind. This is the important thing right here. In fact, it's important. If I keep that in mind, matter of fact, it's doubly important. If I keep it in mind, I can probably get through any of these problems. So what do I know here? This is a logarithm. But what are logarithms? They're exponents. So what you're looking at here is an exponent. So what exponent, now here's the base, what exponent would you put on 3 to get you to 9? Right, so I'm thinking this, right? So this is going to be equivalent to, all right, what's the base? 3. Now, kind of like, what exponent would I put on 3 to get 9? Well, I know that that's 2, right? So I'm going to say then that the log base 3 of 9 is 2. And the way it reads is, the logarithm base 3 of 9 is 2, so the exponent that I would put on 3 to get 9 is 2. Okay, that's just 3 quick examples. We're going to go now into the exercise set in 6.3 and do lots of examples so that we're really going to get a good feel for this.